Okay? So, what is the sine of 135 degrees? Root 2 over 2, and cosine of 135? Negative root 2 over 2. At 135, sine is still positive. Okay? So what am I going to get when I multiply them? The 2's cancel there. Negative root 2 times 2 is a negative 2 over 2, which is negative 1. So again, we get this value, we already knew it was. Right? We already knew that the sine 270 was negative 1. So if you only memorize the top half of the circle, we can get the bottom half using this formula. Next ones are a bit more useful. So these are going to be the power reduction. So we are starting with a sine squared of theta is equal to 1 minus cosine of 2 theta over 2. Cosine squared theta is equal to 1 plus cosine of 2 theta over 2.
Is that at the top of that 1 minus cosine of 2 theta?
Yeah, cosine of 2 theta. And tangent squared theta. 1 minus cosine 2 theta over 1 plus cosine 2 theta. And now that's just sine over cosine. Now, you'll have problems in the homework that say reduce this expression to only first powers of cosine. So you might start with, say, something like this. Sine to the 6th of theta. Write this as only first powers of cosine.
What?
So we need to change it from sine to the 6th to only having first powers of cosine. So cosine to the first. Using this formula. So we can start first by changing it into 1 minus cosine 2 theta over 2 to the third. I just change it to 8, just make it a bit nicer, I think. So, what do I do from here? So I'm going to have to distribute or apply this to 4. So I'm going to take, what's 2 to the 4th? 16. So I'm going to leave it as 1 over 16 out front. And now we have 1 minus cosine 2 theta squared. So what's 1 minus 2 cosine 2 theta squared?
Where did the 4 go?
2 times 2.
Oh.
What basically I want to do is I can square this easier than I can raise it before. Because I can square it in my mind. 1 over 16 times 1 minus 2 cosine 2 theta plus cosine squared of 2 theta squared. What I did is I took this 2 and squared this. And I still have this 2 out front, so 2. Yeah. Okay, now let's apply the squared. Notice this process gets very long sometimes. So 1 over 16. So 1 times 1, I have 1 minus 2 cosine 2 theta plus cosine squared of 2 theta. That's 1 times everything. Now I'm going to take this times everything. So minus 2 cosine 2 theta plus 4 cosine squared of 2 theta minus 2 cosine, say, this times this, and it has cosine cubed of 2 theta and then this one plus cosine squared of 2 theta minus 2 cosine cubed of 2 theta plus cosine to the 4th of 2 theta.
Is that one just like 3 back? No.
1, 2, 3. Cosine squared of 2 theta. Okay, as you notice, this gets very messy. And we're not done. Why not? Because we have combined like terms, but then notice, any of these cosine squares, we're going to have to reduce. And use the same process again. Any of these cosines to the third, we're going to have to reduce.
Can you go back to the end of it?
Any of the cosines to the fourth, we're going to have to reduce the squares, and then we're going to have to do it again. So in other words, this can, I don't think there's any of them this long. I think you might have like cosine to the fourth to reduce. But you're not done until you don't have any exponents and you have all cosines. So I'm not going to finish this problem because it'll probably take the rest of the class period. Yeah? No. But basically, make sure you understand the process that we're doing. Because once we get here, every one of these that have squares, we're going to have to apply the cosine rule. The third, basically, we have to take it into a cosine squared of theta times cosine of theta. Cosine squared you can reduce. And then since they're not going to be unlike terms, they're not going to get multiplied together. So you're going to get cosine theta times some net. Now the ones that are much more useful. The formulas that we find that I think are my favorite of these ones. Half angle formulas. And these ones I've actually considered having you memorize because these ones are, I think, of the ones here are probably the ones you use the most. Sine of theta over 2 is equal to plus or minus square root of 1 minus cosine theta over 2. So cosine of theta over 2 equals plus or minus square root plus cosine theta over 2. And tangent. Tangent, this is the one where tangent is the nicest of the three. 1 minus cosine theta over sine theta, or sine theta over 1 plus cosine theta. So, using this, let's do the cosine of, let's say, 3 pi 8. Get the exact value of cosine 3 pi 8. Now, the first thing you want to do with any of this type of problem is determine, are we going to have a positive answer or a negative answer? How do you know? Okay? Because when you look at it, pi half is here, 3 pi 8 is less than pi half. We know we're in this quadrant, and cosine is positive here. Which means when we're applying this rule, we're wanting the positive square root. If we had, say, 3 pi fifth or something like that, we would have a negative thing. So we know we'd have to be in the second quadrant, would mean we have a negative square root. So what is 3 pi 8 half of?
6 pi 8.
6 pi 8, which is?
3 pi 4.
Yeah. So we can call this, the cosine is 3 pi 4 over 2. Anybody stuck on where we got that? Okay? So, basically what we can do is multiply this by 2, and how does it simplify? 6 pi over 8, and 6 over 8 simplifies to 3 over 4. So if we multiply by 2 here, we're going to divide by 2 to cancel, because we want to keep the same value. So 3 pi 4 divided by 2 is 3 pi 8. So what does it tell us about theta? What is the value of theta? And we are using this rule. Theta would be 3 pi 4. And we know it's going to be the positive square root, because 3 pi, if you look at cosine of 3 pi 8, 3 pi 8 is somewhere here in that neighborhood. If 3 pi 8 is there, then we know cosine is positive in that quadrant. So we're going to have the square root of 1 plus cosine of 3 pi 4 over 2.
I was 1 minus.
For sine is pi. Okay? How does it, what's the cosine of 3 pi 4? Root 2 over 2. So we're going to have the square root of 1 plus root 2 over 2 over 2.
It's not negative.
Okay, yeah, negative. That makes it better. Yeah. 1 minus root 2 over 2 over 2. It's 3 pi 4 cosine 3 pi 4. In case you're in doubt, you do need to make sure you know your unit circle for the upcoming test. If you don't know it, it's going to be very bad. My intention, I'll show you at the end what you're looking at. Yeah, we're going to finish it. So, I was pausing for a second to make sure everybody's caught up. How do I simplify this part right here? Combine the top, what do I get? So 2 minus root 2 over 2 over 2 square root. 2 over 2, what's going to happen? Not going to cancel, but it's going to be 1 over 2 here. Remember, when you split, okay, when you're dividing a fraction by another number, we take the other number, we can make it a fraction, 2 over 1, right?
What?
You see where this came from?
No.
Where this came from? Just a 2 here.
Yes.
Okay? So this part right here just became the top. Because this is on the top of the fraction on the bottom. So this here is 2 over 1. Whereas this is on the bottom here. So we can flip and multiply it, and it's going to become 1/2 multiplying here. That's the rule for dividing a fraction, is you flip and multiply. So on the top, so now we're going to get square root of 2 minus root 2 over 4. Almost done. So we're going to get root 2 minus root 2, and what's the square root of 4? So I'm going to take that out of the square root and get that. And there's my answer. 2 minus square root of 2 minus root 2 all over 2. So how about the sine of pi 12? So remember, we already did pi 12 by doing root 3 or pi thirds minus pi 4, right? However, we can also use the half angle formula. What is pi 12 half of? So we can say that this pi 6 divided by 2. Now, is sine going to be positive or negative? Positive, so I'm going to have positive square root of 1 minus cosine of pi 6 over 2 equals square root. What's cosine of pi 6? Root 3 over 2, so I'm going to do 2 minus root 3 over 2 over 2. That's combining 2 steps. Starting with this 2 over 2. And so we're going to get square root of 2 minus root 3 over 2. So Now, this is not the same value as we got, or this does not look the same as what we got when we did like pi thirds minus pi fourths. Right? We didn't get any ones where that's a square root and a square root. However, if you plug them both into your calculator, you get the exact same answer. Now, one more set of formulas. These are the interesting ones. Sine of A times sine of B. So you got two things that are multiplied. Is equal to 1/2 the cosine of A minus B minus the cosine of A plus B.
What are these called?
These are your product sum rules. So we have a product here, and we get a sum. Next one. That's sine. You have cosine A, cosine B. Any guesses what it's going to look like? And sine A, cosine B. What do you expect this one? Any guesses? Okay, 1/2. Now, would it make a difference if I changed this and said, say the sine or the cosine of A sine of B? Is there going to be much difference between these? Okay. Your book has two separate formulas. However, arbitrarily, we can change the orders here, right? When you're multiplying, doesn't matter the order. No, so I can change this and write this as sine of B cosine of A. And then I can just use the same formula. It's just swapping all the A's for B's and B's for A's. Because if we change the order, notice it's changing this to B minus A. Yes. Yes, I know. But if you change this to a minus here, then you can change it to B minus A. So remember, if you have sine of negative theta is the same as negative sine of theta. That's basically the rule we're using. I can change this to -1 times B minus A, and say this is negative theta. And then I can change it and make it negative sine of theta. So it's the same rule, it's just reordered a little different. Right. Yeah. Okay, so example of one of these problems. Let's say cosine of 20 degrees times cosine of 40 degrees. Actually, two. Instead of 15 and 45, make it easier for us. 15 degrees and 45 degrees. Yep. So applying the rule, we have 1/2 cosine of, what is A minus B? A 30 degrees plus cosine of 60 degrees. What is the cosine of 30 degrees? Or negative 30 degrees? Not saying it's cosine of 30 degrees. What's the cosine of negative 30? 3/2. 3/2 plus cosine 60 degrees. Okay, so I get root 3 plus 1 over 4. And I'm taking this 2 out front. Combining these two, since there's common denominator, we can just add them together and multiply by 1/2.